A bit later on in this course, I've got lectures that describe in some detail the various tools that you need in your electronics adventures. But in this lecture here, I'd like to walk you through the absolutely basic and necessary tools that you need for this particular course. And those tools are fewer than you may think originally. You don't need that much in order to have fun with electronics. So let's have a look. Obviously, you will need a soldering iron. The thing is that many of the parts that you'll be buying in order to integrate with your Arduino gadgets will not come soldered, will not come assembled. For example, in the previous lecture, I mentioned that having a LCD shield like this one that combines the LCD screen plus buttons is a good idea. And the problem is that when you buy one of those, all the parts that you see now soldered onto the board are loose. They come in a bag and you have to put them all together by soldering them onto the PCB. Of course, to do that, you will need a soldering iron. Now, again, because we are doing microelectronics, a soldering iron doesn't need to be anything fancy or expensive. This one here is just a 20-watt soldering iron with a turbo boost to 130 watts in order to get it to heat up faster. That's what the red button is for. And you can get this for about $15. Whichever tip comes with is fine to use. Now, with a soldering iron, you will also need solder. So the one that I use here is leaded solder. Watch my lecture on soldering because I've got a bit of information about the leaded versus lead-free solder. The thing to know at this point about the difference between the two types of solder is that leaded solder is easier to use, especially when you are a beginner. It's more malleable and it can melt at a lower temperature. So a lot of beginners find it easier to begin with leaded solder, but you need to be also familiar with the health implications of using this type of solder. So personally, especially if you're a younger person or if you're a parent purchasing solder for your children, I would definitely go with a lead-free solder. More about this topic, of course, in the dedicated lecture on soldering. Now, in order to be comfortable with your soldering jobs, you will need a contraption like this one, holding hands. This allows me to put a device that I'm working on, secure it against my holding hand, so then I can go ahead and do the soldering without having to chase parts on my table. So comes very often with a magnifying glass, so you can have an easier time working on very small parts. So get yourself some kind of device to hold the board that you're working on in place while you're doing your soldering. So I find this necessary. Also good for protecting your table from burns. Okay, so you need one of those. Obviously, breadboards. I typically tend to use two different kinds. This is a mini and a micro soldering board. I rarely find myself working with a larger breadboard, so I strongly recommend that you get at least, say, 5 of those mini breadboards. They seem to be the right size. And you can also combine one next to the other if you need a little bit more real estate. But as we're getting started, our circuits will tend to be smaller rather than larger, so you can easily get a lot done at this size. So I'll get a bunch of breadboards. This is a solder pump. So as you are working soldering components onto a PCB, very often you make mistakes. So you want to desolder a part, that is to remove solder from the part so that you can repair it or change it. So this is a solder or a desoldering pump that essentially sucks the solder, the hot solder, so that it can remove it from the breadboard and you can do your repair. It's a very cheap part. Strongly recommend that you have one of those. And in an upcoming lecture, I'm also showing you how to use these. You need screwdrivers, so small precision screwdrivers are necessary. Some of the parts that you use very often have got little potentiometers for calibration, like this one here. So you need a screwdriver to be able to operate those small parts or small potentiometers. So that's one. Another example would be, where did I put it? Here you go. The PS sensor, the pyrolytic motion sensor. So this has got two calibration potentiometers, and again you need a screwdriver. So any small precision screwdriver would do. Then we need wire cutters in order to not just cut wires, but also to trim the soldering work that you've done from a PCB. So for example, this sensor, this is the BME 280. It comes with the PCB separate to the header, and you need to attach the header and solder it on. So very often that ends up with a lot of blobs of solder over the pins. So you can use your cutting tool to just trim up the excess solder or any pins that are sticking out too far. So absolutely necessary tool to have, precision cutters. I also like my tweezers a lot. With my tweezers, I can place small components onto the breadboard like this. So you can manipulate very small parts. So these are tweezers that are non-magnetic and anti-static, which are very good and advisable to use with microelectronics. I'm going to be talking about those as well in a separate lecture further down in this course. You will need lots of wires. So typically the wires that we use with Arduino projects are wires like these, male to male. So both ends are male. You can get them in different sizes as well. And I keep them all together in a box like this, so I can take out whatever I need. So this one is a longer male to male jumper wire. So the more of these you get, the better it is. You never want to run out of jumper wires. And last but not least, you will need a very simple multimeter. In this course, we don't do anything fancy with a multimeter other than to measure the voltage, the continuity, the resistance, the resistance is up here, and the current that is flowing through a part. Literally a $10 multimeter will do just fine for everything you need to do throughout this course. There are more expensive multimeters, of course. If you want to spend a little bit more money on a multimeter, like $20 instead of $10, then you can find yourself an auto-ranging multimeter, which means that the multimeter itself will be able to detect the range of the value that you're measuring, so you don't have to play around with the diode trying to put it at the right setting. The multimeter will do that for you, but you can get something like that for $20. Again, that's nothing fancy, and if you can afford an auto-ranging multimeter, then I would recommend that you go for one of those. Okay, so that's about tools. As you can see, there's not many tools that you need. You can do a lot with a small number of essential tools.